Okay, another reason why we might use a determinant is to be able to write or to evaluate this kind of a matrix. And to ask you to do this a number of times in the textbook. There's an example like it, but I'm just going through one similar, same kind of deal, but just to show you the steps that we take. So it tells you it wants to solve this matrix, but wants you to find the determinant of a minus ki, to then write this p k squared plus qk plus r, and then use that to be able to solve this thing here. So let's see, we've got a matrix here of A. Now, to find the determinant of A minus ki, we've got to write a matrix A minus ki. Now, I, we know, is the identity matrix. So then ki equals k0, 0, k. Right. Now, if we're doing a determinant of that, we've got to work out A minus this. So A minus ki equals 2 minus k, then negative 3 minus 0, negative 1 minus 0, and negative 4 minus k. So that's what we have there. That's what that is. So then our determinant of A minus ki equals 2 minus k, and we're going to multiply that by negative 4 minus k, and we take away negative 3 times negative 1. So from there we end up expanding this and we get k squared plus 2k minus 8, and this here ends up being minus 3. Continue to simplify, and k squared plus 2k minus 11. Now what we see is that this is written in this form. So we equate the both equations, and we solve for coefficients. So coefficient of k squared here is 1. So therefore p equals 1. The coefficient of k is 2. So q equals 2. And our constant at the end, r, is negative 11. Okay, now that we've got that, we can go off and solve this matrix. So then we've got a squared plus 2a minus minus 11i. Now, in terms of working this thing out, we know that 11i ends up being 11, 0, 0, 11. And now we've got to do some evaluation. So a squared, I'm just going to put a line through all this here. Makes it easy for me to work with. A squared equals 2, negative 3, negative 1, negative 4, which is 2, times by itself. So we have 2, negative 3, negative 1, negative 4. And from there we end up with 7, 6, 2, and 19. So that's what we sort of shoot here. So now we've got a squared, 7, 6, 2, 19, plus 2 times a, which is 4, minus 6, minus 1, and 4, minus 8, minus 11, 0, 0, 11. And then we go off, we work this out. So you got 7 plus 4 gives us 11, minus 11, we end up with 0. And remember we've got a 2 by 2, so we're going to have 4 elements. So then 6 minus 6 gives us 0, minus 0 also gives us 0. Next one along, 2, it should be negative 2 here, because it's 2 times negative 1. So here we've got 2 minus 2 to give us 0, plus 0 will also give us 0. Put in a negative there so you actually see it. And then the last one, we've got 19 minus 8 to give us 11, minus 11 will also give us 0. So that's how we go about solving these. So we write down our matrix, our two equations, determinant of A minus Ki, set up what I is, Ki, put it into a matrix, A minus Ki, so A2 minus K, negative 3 minus 0, negative 1 minus 0, negative 4 minus K, so that's what we end up with there. Take the determinant, we multiply diagonally opposite terms and subtract. And then from there we equate coefficients, and from there we can safely go off and put it into the matrix and then evaluate the matrix.